We all know this action, but have you ever seen this? Every single day, millions of Americans pour liquid eggs from a carton without knowing the incredible, high-speed journey it just took. This is the full process, and it changes everything you thought you knew about eggs. But behind that simple and familiar action is one of the most tightly controlled food production processes in the United States. A process that begins not inside a factory, but inside a barn, on a farm, often hours before the first processing shift even starts. This is the full journey of an egg. From the moment it is laid to the moment it is sealed inside a refrigerated carton and loaded onto a truck headed for a grocery store near you. It starts on large commercial egg farms, most of them located in the Midwest, where climate control, feeding schedules, and lighting cycles are carefully engineered to maximize consistent production output across the entire flock. These facilities house hundreds of thousands of hens, each one laying on a predictable biological schedule driven by environment, light exposure, and nutrition. The eggs do not sit. The moment a hen lays, the egg rolls gently down a sloped surface onto a conveyor belt that runs the full length of the barn. These belts move slowly and continuously, collecting eggs from every row without interruption or manual handling at this stage. From the belt, the eggs travel to a central gathering point inside the farm, where they are loaded into large plastic trays called flats. Each flat holds 30 eggs. Flats are stacked onto trolleys, and trolleys are rolled into refrigerated holding areas within the farm building itself. Temperature management begins here, not at the factory. Eggs that are not cooled quickly after laying begin to develop bacteria inside the shell. At commercial scale, that is not a risk anyone in the supply chain is willing to accept. Refrigerated trucks arrive at the farm on a defined schedule. Loading is fast and systematic. Flats are transferred from the holding area into the trailer, organized by collection time and farm of origin. The driver logs the departure time, the internal trailer temperature, and the confirmed destination. The journey to the processing facility can take anywhere from 1 hour to several, depending on the distance between farm and plant. But once that truck backs into the receiving dock, everything changes. From this point forward, nothing about these eggs will ever look the same again. The receiving dock of a large liquid egg processing plant is one of the busiest and most precisely managed areas in the entire operation. Trucks back into temperature-controlled bays where the incoming load is immediately assessed by trained receiving staff. Inspectors record the internal trailer temperature on arrival, verify the farm origin documentation against the delivery schedule, and confirm the physical egg count against the transport manifest before anything is unloaded. Any count discrepancy triggers a hold on the entire delivery. Any temperature reading outside the approved range results in full rejection of the load, regardless of how far the truck traveled to get there. This level of scrutiny is not a formality. Every carton of liquid egg that leaves this facility is only as safe as the incoming product that entered it. The chain of custody begins here, and it does not break from this moment forward. Once cleared, the flats are transferred onto intake conveyors that carry the eggs into the first major inspection stage, candling. Candling is one of the oldest egg inspection techniques still used in the industry, though the modern version looks nothing like its origins. High-intensity LED arrays shine through each egg as it passes along the conveyor line. Camera systems capture a real-time interior silhouette of each individual unit. Inspectors and automated detection systems look for a defined set of defects: hairline cracks in the shell, blood spots inside the egg, abnormal air cell development, or a yolk that has broken before the egg was ever opened. Any egg that fails this check is diverted from the line before it can advance further. What passes candling moves directly into the washing system. Each egg is sprayed with warm water containing a food-safe sanitizing agent. Federal regulations require the wash water temperature to reach at least 90 degrees Fahrenheit and remain warmer than the internal egg temperature throughout the entire cycle. This prevents bacteria from being drawn inward through the microscopic pores of the shell under pressure. Rotating brushes move along the surface of each egg during washing, removing surface debris and environmental residue carried in from the farm environment. After washing, eggs pass through a drying section and receive a fine mist of food-grade mineral oil, sealing the shell pores and extending shelf stability for the days of handling ahead. From here, the eggs move toward the most consequential step in this entire operation, the break. Breaking eggs at industrial scale is nothing like cracking one over a pan at home. The breaking machines used in large liquid egg processing facilities handle thousands of eggs per hour, each one processed individually in a continuous automated sequence that runs without stopping for the full duration of a production shift. Eggs arrive at the breaking section on conveyors, oriented so that each one enters the machine at the same angle and consistent speed. The machine holds each egg in rubber-lined cups, positions it over a brake blade, and opens it with a controlled mechanical strike calibrated to separate the shell cleanly without fragmenting it into the liquid contents below. The two halves of the shell open. The contents drop into a receiving cup positioned directly beneath the break point. At this moment, each egg receives one final individual inspection before it joins the main product stream. A camera system and a trained operator positioned at a glass-walled inspection station both assess each egg as it drops from the cup. Off-color yolks, blood spots not caught during candling, or any visible shell contamination are identified at this point. That specific cup is diverted automatically without interrupting the rest of the production line. What clears final inspection drops into the processing flow. Whole egg, yolk, and albumin can be directed into separate streams depending on the product specification currently running on the line. For liquid whole egg, the contents flow together into a single collection system. For specialty products, yolk and white are mechanically separated by the geometry of the cup design itself. The liquid is raw at this stage. Under United States federal regulation, raw liquid egg cannot be sold commercially without passing through one critical treatment first: pasteurization. The liquid egg is pumped through a plate heat exchanger, raised to a sustained temperature between 140 and 145 degrees Fahrenheit, and held there for a precisely controlled and validated period of time. This combination of heat and duration destroys salmonella and other regulated pathogens without cooking the protein or degrading the functional properties that make liquid egg commercially valuable as a food ingredient. Temperature is monitored continuously by calibrated sensors at multiple points in the system. Flow rate is regulated to guarantee full thermal exposure. Every single hour, over 5,000 gallons of liquid egg passes through this system, ensuring that what was raw 60 seconds ago is now completely commercially safe. After pasteurization, the liquid is rapidly chilled and moves into the filling line. The filling line is where liquid egg finally becomes the product most consumers recognize when they reach for it in a grocery cooler. Chilled, pasteurized liquid egg arrives at the filling station through a sealed, sanitary stainless steel pipeline. Nothing about the product is exposed to open air at any point from here forward. The closed-loop system is designed specifically to prevent any recontamination of a product that has already been rendered commercially safe. The cartons arrive at the line in a flat, compressed format. A forming machine opens each one, shapes it into its rectangular body, and heat seals the base in a single motion that takes under 2 seconds per carton. Hundreds of cartons are formed and positioned every minute, each one moving in a continuous column toward the filling nozzles. Each carton stops briefly beneath a filling head. The nozzle dispenses a precise measured volume of liquid egg, controlled by weight sensors embedded in the line beneath each fill position. If the fill weight falls outside the programmed tolerance by even a fraction of a gram, the carton is flagged and automatically removed before it advances to the sealing stage. This matters on 2 levels. Regulatory compliance requires that sold volumes match declared volumes on the label, and at the production scale of a large facility, consistent fill weight directly controls product cost across millions of individual units. After filling, the top panel of each carton is folded and sealed under heat and pressure. Seal integrity is verified by the machine's own internal sensors. A carton that does not achieve a complete seal is pulled from the line without any human intervention required. At the same station, date codes and batch identifiers are printed directly onto each carton. These codes connect every unit to the specific farm, collection date, and production shift that created it. Traceability is not optional. It is built into every carton that leaves this facility. Laboratory samples are pulled from the filling line at scheduled intervals throughout the shift. Technicians test for microbial counts, verify pasteurization performance, and confirm that the nutritional profile matches what is printed on the label. If this kind of process genuinely interests you, subscribe to this channel right now. Every week, we step inside facilities like this one and show you exactly how the products you use every day are actually made. The cartons are sealed. One stage remains. Filled, sealed, and coated cartons exit the filling line and enter the final section of the facility: cold packing, palletizing, and distribution staging. The first stop is the case packer. Individual cartons are grouped and loaded into corrugated shipping cases by an automated system that counts, orients, and places each carton in a defined arrangement. The case configuration is designed to maximize pallet density and minimize product movement during transit in a refrigerated trailer. Each completed case is sealed, printed with a product and destination code, and transferred to the palletizing station. A robotic arm picks cases from the conveyor and stacks them onto a pallet in a predetermined pattern that matches the structural and logistical requirements of the retail distribution centers receiving the product. Completed pallets move to an automatic stretch wrapper, which spirals a continuous layer of film around the entire stack while the pallet base rotates. The wrap stabilizes the load against shifting and provides a secondary barrier against handling contamination in the warehouse and during transit. Wrapped pallets are scanned into the warehouse management system at the entry to the cold storage room. From this point forward, every pallet has a tracked identity. Its location within the warehouse is recorded. Its scheduled departure is confirmed against an outbound order before any dock door is opened. The cold storage room itself is maintained between 33 and 38 degrees Fahrenheit at all times. Temperature sensors monitor multiple zones throughout the room continuously. Any reading outside the approved range triggers an automated alert that reaches the quality and operations teams immediately. Refrigerated distribution trucks arrive on a rolling schedule and back into assigned loading bays. Pallets are loaded in reverse stop order, so the first delivery point receives product loaded closest to the rear door. The loading log captures the truck identification, departure time, trailer temperature at seal, and the identity of every pallet loaded. The truck leaves. The cold chain continues without interruption from this warehouse to the distribution center, from the distribution center to the retail store, and from the retail shelf to the cooler in your kitchen. Most people never think about any of this when they reach for a carton, but somewhere between a barn in Iowa and a refrigerator near you, hundreds of people, thousands of machines, and an unbroken chain of temperature inspection and precision made that moment possible. That is what this process actually is.